Alright guys, so this video is going to show you what your diagram looks like if you're looking at the sun, moon, and earth from above, okay? Remember, there's only one moon around earth, but this diagram has got 8 moons on it because there are 8 distinct phases of the moon. We're going to explain why that's important when we look at this today. Alright, so first thing, as always, I'm going to add my arrows for the direction of the moon's orbit around Earth. So I'm going to go ahead and draw those on this diagram. And the moon orbits counterclockwise, so it goes against the clock. So instead of going 12, 1, 2, 3, 4, 5, 6, you would go 12, 11, 10, 9, 8, 7, 6. Okay, so that is against the clock. That is what counterclockwise means. All right, so I'm going to start right here with this easier moon phase. In my opinion, this one here is one of the easiest ones to talk about. This is our new moon phase, okay? So normally when they talk about moon phases, they usually start with new moon. That's just kind of the way it is. I'm not sure exactly why, but in my opinion, it makes things a little bit easier. All right, so if we're looking at this moon, we're looking at from above. We know that the sun is what gives the moon its light. So the half facing the sun is what's going to be bright. So if we imagine that like a little ping pong ball sitting on the page, we know that the half facing the sun is going to be bright and the half facing away from the sun is going to be dark. Okay, so I'm going ahead and shaded that one in, and I'm going to go ahead just for sanity's sake and label this as the new moon. Okay, just so we remember what I'm talking about for this point. Okay, all right. So if we are looking at this diagram, just to kind of help you understand what we're looking at, this is not drawn to scale. Okay, the moon is a lot smaller compared to Earth. The sun is a lot larger compared to the moon and Earth. The sun is a lot farther away, and so is the moon. The moon is a lot farther away from Earth. So this diagram is not perfect, but it does help us understand what we're talking about as far as moon phases, okay? So if we're looking at this from above, no matter where the moon is in its orbit, the half that's facing the sun is bright, and the half that's facing away from the sun is going to be dark, okay? So all of these moons on this diagram are going to look exactly the same, okay? So half of the moon is always bright, and it's always the half that's facing the sun. And this is where it's important to remember the diagram is not drawn to scale, okay? So if I was going to draw this, it would look like the half facing the sun would be kind of tilted in this direction towards the sun, but it's not. And that's because the sun is so much farther away. So if you're looking at this from above and we're looking at it in real life, the moon looks exactly the same no matter where it is in its orbit around Earth. If we're looking at it from above, they're all going to look exactly the same. Okay, so I'm going to go ahead and color these in, and then I'll explain how we can use this diagram to tell us where each moon phase is and why we see the moon phases the way we do. Okay, now these are not going to be perfect, so when you do yours, you don't have to make sure it's perfect. Just make sure that you are coloring them the right way so that you know which part is dark and which part is bright. All right, so now I've got all my moons drawn on here. So we're looking at them from above. The half that is facing the sun is what is always bright because we know that the sun, the sun is where the moon's light comes from. Okay, so I am going to color the sun just for fun because I can. And then I'm going to talk about why this is so useful for us. Okay, so just to be helpful, I'm going to remind us that what's left, that what we didn't color in before, that's what's bright. Okay, so it matches the sun since the moon is getting its light from the sun. It's kind of like a big mirror that's floating around in the sky. And this is going to help us out with our other diagram about where each moon phase belongs. All right. So now let's talk about standing on Earth and looking at the moon. All right. So I am going to put a little star right here. Imagine I'm standing on top of that star and I am looking at this moon right here. That would be our new moon phase. The only thing I can see is the half that's facing Earth. So I can't see any of this brightness that's over here on the other side. So from Earth, this looks completely dark. So that's why it is our new moon phase. Okay? Now, if I'm standing right here on Earth and I'm looking at this moon right there, looking straight at it from Earth, I can only see the half that is facing the Earth. Okay, in this case, I can see some of the brightness. It looks like about half of the moon is bright right here, and half of the moon is dark on this side. And this is my right-hand side, since I'm looking this way, and this is my left-hand side. So when I'm looking at this moon, I can tell the right half is bright and the left half is dark. So if I know the right half is bright and the left is dark, this is my first quarter moon. Okay, so this can help us figure out where the moon phases are and why we see them the way we do here on Earth. And I'm going to show you one more. All right, let's imagine I'm standing on Earth and I'm looking at this moon right here. And now, since I'm looking this way, this ends up being my left-hand side and this ends up being my right-hand side. Okay, since I am looking this way, I'm facing almost down towards this moon. And I can see the half that is facing Earth. So it's bright right here on the left-hand side, and it's dark on the left-hand side. Oops, I said that backwards. Okay, it is bright on the left-hand side, and it is dark on the right-hand side. So I know that if it is bright on the left, that is my last quarter moon phase. All right, and when you're doing this with your diagram, you'll be able to spin your diagram around a little bit. You'll be able to turn it so you're looking at it as if you were actually sitting on Earth. So that should help you a little bit. Just to be careful with this one, remember that if you are looking from Earth, this will be your left and this will be your right. Okay, and up here, because I'm looking this way, I don't have to flip them. This is my right-hand side and this is my left-hand side. Okay. All right, so this kind of helps us understand why we see things the way we do. All right, now, even though the moon looks exactly the same no matter where it is in its orbit, it looks exactly the same from above. If we were watching them from outer space, the moon would never look like it changed. But the reason we see moon phases while we're sitting here on Earth is because of our perspective. So right here, this first one that I talked about, I can't see any of that brightness on the moon. And if the moon didn't move, we wouldn't be able to see it from Earth unless we were deliberately looking for it with a special telescope and maybe shining some of our own light on it. But because the moon orbits around Earth the way it does, we are able to see part of that brightness as it orbits. So this moon right here, this one, all I can see is brightness. I can't see any of the dark that's on the other side. So if the moon stayed here all the time, we'd always have a full moon. It would always be bright outside. But because the moon orbits, we're able to see a change in the moon phase because it's orbiting us and because we're looking at it from Earth. Okay, so that is why we see moon phases.